Hi, today we're going to talk about how you can protect your artwork against changes to its external dependencies and how you can make sure that your art code will work for as long as it needs to work. Now let's consider two scenarios. In the first scenario, you have a piece of art code that has been working perfectly fine for a very long time, but now all of a sudden it stops working. What could that be? After hours spending investigating the issue, checking if anything has changed in the input data, if anything has changed in the code, you finally realize that the problem is that one of your dependencies has been upgraded and the new version is not compatible with your code base. In the second scenario, you have a perfectly working piece of art code that you're sharing with one of your colleagues. They try to run your code, but it doesn't work. So why could that be? Again, after hours spent investigating the issue, you realize that the problem is that your colleague is using some versions of the dependencies that are different from yours, and the two are incompatible. So how can we fix these two problems? Well, before we can fix them, we need to understand why we have the problem. And in both cases, the problem is with the environment. Specifically, in the first case, we could not protect our code against external changes to the environment. And in the second scenario, our colleague could not replicate the exact same environment we were using. So why this is happening? Well, in R, by default, all your dependencies, all your packages are going to be installed in a central library. That central library is shared with all of your projects. So if something changes in that library, for instance, your IT department decides to upgrade a package, then potentially all your projects, depending on that package, might stop working. So we need something better than base R. We need an environment manager that can create a library that is specific to our project, and it can also create some sort of list of all the dependencies that we are using and the exact same version of those dependencies. So enter renv. Renv, which is short for reproducible environment, is an R package that does two main things. It creates a library that is specific to your project, and it creates a list of all your dependencies and the exact same version of those dependencies. So that's exactly what we need. For those of you a little bit more familiar with R, this might sound familiar, and this is because what renv is doing is exactly what Packrat was doing. And in fact, renv is an upgraded version of Packrat, just more reliable and easier to use. And as of today, you shouldn't be using Packrat anymore. In fact, renv even gives you an easy way to migrate your Packrat project to a renv project by using the migrate function. So now that we know why we should be using renv, let's have a look at how we can use it. The first thing you need to do is to tell RStudio that you want to use renv. This is called activating renv. There are different ways of doing it, and I'm going to show you the main three. Now, the first option is to activate renv when you create a new project. So if you try to create a new project, you don't need to save right now. We can create it in a new directory, yes, a new project. As you can see, after you give it a name, you have the option to tick this box that says use renv with this project. I'm going to cancel now, but that's your option number one. Option number two is to create the project first and then activate renv from the settings. And this is what I'm going to show you right now. I just created a brand new project. It's not using renv yet, but if we go into the settings, we have a tab called environments, and as you can see, we have the same tick box that says use renv with this project, and it's going to do exactly the same thing, activating renv. I'm going to cancel again. Now, regardless of which of the two options you choose, the effect is going to be the same. RStudio behind the scenes is going to run a command called renv activate, and that's your third option, which is actually activate manually. So if we do that, as you can see, we are now renv active, and we have a couple of new files and folders that appeared. So let's have a look at those files and folders. The first file is rprofile. So rprofile is run by RStudio every time you load or reload your session, and it's simply initializing the renv machinery by sourcing the file called activate.r, which we'll see in a minute. So if we go into the renv folder, we can see we have a git ignore. Essentially, the git ignore is telling Git to ignore the library and local folders, which are the locations where your dependencies are going to be installed. And the reason why you want to do that is because they're going to be very, very large folders, and they're going to be easily recreated by using another file. So there's really no reason why you should to upload them to the repository. Another file is activate.r, and you don't need to go into the details of this. Of course, you can if you want, but this is really the core of initializing the renv machinery. So every time the R session starts, the R profile is going to run all this file to initialize the renv machinery. And finally, library and local are two folders where your library, your dependencies are going to be installed. And for instance, if we go into library, I'm using R4.1. I'm on a Mac, and as you can see, we have renv installed, and at the moment it's the only package we have installed because we don't have any other dependency. So with this, we have solved the first of our problem, which was to be able to create a library of dependencies which is specific to our project, as this is not affected and is not going to be affecting any other projects or any other library you might have in your computer. We still have another problem though, which is to record somehow all the dependencies and the versions in a file, so we can share that information with other developers in a way that they can then recreate the exact same environment. So let's have a look at how we can do that. Let's install a new dependency first of all, and we can do that using your standard install packages. Install packages, and let's install dplyr. Okay, now dplyr is installed, and in fact, if we look into our renv library, you can see that we have now dplyr installed along with many other packages that dplyr depends on, for instance magrittr or R6. Now, if we try to create the file to store the information about the packages, let's see what happens. To do that, we need to create a snapshot of our system. So that's renv snapshot. We can say yes. Okay, so now we have a new file, which is renv.log. Let's have a look at that file. Renv.log. Right, here it is. So as you can see, it's specified in a JSON format that we're using R version 4.1.0, and that we have renv as a dependency, and nothing else. At the moment is not mentioning dplyr or any other package. And why is that? The reason why there's not a dependency other than renv listed in the renv.log is because when you create a snapshot, renv is going to go through your code base to check which libraries you've loaded. Now, at the moment, we don't really have a code base, so even if we install dplyr, we're not using the package. What we need to do is to use it somewhere. So to do that, we can go into our code base, for instance in R and this sample file, and we can load the library. So library, and it's going to be dplyr. We can save it, and if we run the snapshot again, say yes, let's check renv.log, and there you go. Right now, we have a lot more dependencies listed, including our dplyr, but also all the dependencies that dplyr needs. Last thing I want to show you is how you can use the information in renv.log to restore your library after you re-clone the project from the repository. So to do that, I'm going to commit the changes we just made to the remote. Then I'm going to delete this project and clone it again from the remote. And I'll see you after all of that is done. Here we are. I just cloned the repository again from the remote. And just to show you, it is a brand new project. If we go into renv and then library, we have only renv installed. There's no other dependency. dplyr is not there yet. However, RStudio has detected that we're using renv. That's because of the R profile file. So the machine has been initialized. And RStudio is also telling us what we need to do to restore our library. We need to run this command, renv restore. So let's do that. We can say yes. So it's done. And if we check again into our library, there we go. We have all the packages that we had before, and all are the same exact version as before. And that is guaranteed by the renv.log file. So as we can see, having the renv.log file is solving the second of our problems, which was finding a way to store all our dependencies and the versions and share that information with other developers so that they can recreate the exact same environment we're using. Before we wrap it up, it's important to mention renv limitations. Now, renv can go a long way in guaranteeing that you'll have a reproducible environment, but it cannot capture everything. renv cannot capture system-wide dependencies. Sometimes your code might depend on a specific version of a system library, like a C++ compiler, or it might require libraries like Panzoc. It might even require a specific operating system, like Unix rather than Windows. renv cannot capture any of that. If this is a problem in your work, the industry standard to address this issue is to Dockerize your solution, or at least test your code against as many machines as possible. And that's it. So today we saw why it is important to manage your environment and to keep track of all your dependencies. We saw how renv is the tool that can help us achieve this goal by using 3 simple commands: activate, snapshot, restore. And with that, that's everything. Thank you for watching, and see you the next time.